Welcome to Mic'd Up. Please welcome Elizabeth Blackburn in conversation with Joon.
If there's one thing that we all have in common more than using one of these Apple devices is actually the fact that if we're lucky enough, we're also going to age. My name is Joon. I'm president of Alto Investors, formerly a physician at Stanford. I was on the faculty there, and I've been at a hedge fund for 19 years. And with me today is Dr. Elizabeth Blackburn, president of the Salk Institute. She's one of the most decorated scientists in the world. Among her achievements, she's won the Nobel Prize for medicine or physiology in 2009 for her work on telomeres and the role of telomeres in aging. She also has been named one of the 100 most important people in the world by Time magazine. She's also the author of a book called The Telomere Effect. And today, we're going to be talking about both the book and Elizabeth Blackburn's role in really helping push the field of aging forward. So thank you for joining us today.
My pleasure. Thank you, Joon.
Can you tell us more about your personal background, how you got to be a scientist and your interest in telomere research?
Well, I grew up far away in Tasmania, which is the bottom part of Australia, and I probably had time on my hands, right? So I just loved looking at nature. I liked animals a whole lot, and I just decided living things were the most interesting thing in the world. And then I just got feeling maybe the molecules in living things were the way that you'd figure out how they worked, and so it just naturally happened that I never had a question. I wanted to become a scientist, and I knew biology was going to be at the center of it. And I just really wanted to figure out how all this was working. I read a wonderful book when I was in middle school about Marie Curie. Now, she wasn't a biologist, but she was a chemist, physicist. She won the Nobel Prize not once but twice, and so she was a great role model. But for kind of an interesting reason, she was also a mom. And she sometimes would homeschool her kids and neighbor kids, and I just loved that combination of the person she was and then this scientist who was very, she saw science as a very high kind of calling. So as a kid you get inspired by figures, and she was one. But it was because I loved just how living things were working.
She's an example of a notable basic scientist. Can you speak to
Yes.
the role of the importance of basic science and research?
Yes. Well, the U.S. is just invested in basic science, and it shows, because tremendous things come out of really understanding how nature works. Be it physics, be it chemistry, be it material science, be it biology, be it us. We're biology, but we're also so much more. We're minds and social beings, and just understanding all of that. To me, using how you can bring scientific thinking to these things just brings such a richer understanding of what humans are all about. And that's what I've loved, is seeing that evolution in the last few decades of more and more technological advances that let you do the kind of science that let you ask now really complex questions about how we as humans are. I started life with single-celled. I started working my career, my science life began with little single-celled organisms, because that's all people felt they had the kind of technology to deal with in terms of molecular biology. And it's just grown and grown. So now we can really do wonderful research that touches quite directly on how humans work, which is way, way, way more complicated, and we're not there yet. But it's such a journey, and it's been such an investment that's been worthwhile, because it really yields the impact to look deeply into how things work, and then they can be translated into products, into health improving, medications, health improving, interventions, things that we do to improve the quality of life, because we're living longer and longer, as you said, and it's all about how do we potentiate these lives. Saying aging is like, oh, it's this terrible problem. I think it's an opportunity. It's really potentiating what you can do with these amazing brains, so long as we're kept in a sort of a healthy enough state that we actually can realize that potential. So that's how I see the research going, is to say, how do we, maximize this human potential that we have in, what is a demographically aging population worldwide. But, we look more and more, and it's not a joke, 70 is the new 50, or is it vice versa? Right. 70, right.
Well, in addition to being a renowned scientist researcher, you're also a great storyteller, as attested by your book. Can you tell us the story of the moment of discovery for you and your colleagues?
Well, I co-authored this book with a health psychologist, Alyssa Epple, whose specialty is understanding the role of severe chronic psychological stress on human mind's well-being and body's well-being. And there's a lot of physiology that happens depending on how your mind is and your state of mind, your habits of mind. And all of this has been something that, when it met the field of telomere research, which is what we started in the early 2000s, suddenly we got a connection in a very real way that we could quantify in terms of how well our telomeres, which are the protective tips that protect the ends of our chromosomes. So I always say they're like shoelace tips that protect the end of your shoelace from fraying. Think of telomeres as what protects the ends of your chromosomes, which carry all the genetic material that makes every cell work well. So you need it working properly. And when those tips wear down, then the chromosomes, the genetic material, is not protected. Cells then say, uh-oh, bad news. They die, they send out alarm signals. And that kind of wearing down of telomeres, we live so many years now, it starts to take a toll. But what was fascinating, and why we wrote the book, was that we realized that while there was bad news about stress and negative sorts of, bad habits, bad sorts of things that happen in people's health-related activities, that while that would wear down telomeres faster, and then lead to the kinds of diseases that come from the fact that our cells no longer replenish, they senesce, they send out pro-inflammatory, sometimes pro-tumorigenic things. That happens, over the decades. But the good news was that this was quite malleable, and people could do a surprising number of, very doable things about alleviating that, so that you can actually improve your telomere maintenance rates quite a lot. So that was the empowering part. We just thought there's so much research coming from all sorts of different quarters, and that was all in these specialty journals here and here and here, and yet we're an integrated entity, and we wanted to make sure that it was all in one place, but heavily backed up by all the great science. But, I tell everybody, I didn't write this book for my science colleagues. They can read the papers. I wrote this book, as did Alyssa, because we wanted this useful information to get out there, because there was so much science there, but you had to integrate it. And we were just fortunate over the years to have collaborated with so many different people in different health and medical and clinical and just general scientific expertises, that we kind of could see the picture, because we'd been collaborating for well over 15 years on these kinds of things. So we got a picture. We thought, we've got to share this. So we wrote a book, because that was the goal, was to share the information and make sure that useful information was out there.
I loved your quote about science being a team sport. It really is.
Yes.
And the aging field certainly is. What are some of the things we can do to improve our telomere health? I think we all, we're all a little terrified learning about what's going wrong with our body, but in the book you really talk about ways to improve your telomere health. First starting with mental health.
Right. Well, so the word stress, it turns out, it's actually a really oversimplified word, because essentially, now I'm learning all of this too, of course, because this is my expertise came from molecules and cells and coming from that end of things. But having worked with colleagues, I've started to learn this. So I will relay it to you, which is that there's challenge stress and there's health stress. So I always say, we're up on the stage, we're under some challenge stress here, and this is good. Threat. Did I say health? It's threat stress. So there's really two different kinds of ways when a stressful situation comes in, people react, and people will have habitual ways they react, but it turns out you can learn with some fairly simple thinking about just how to approach it. Turns out you can relearn how to turn threat stress responses into challenge stress responses, and it's not rocket science. It's really just a resetting of how you approach questions. So that was the thing I found very interesting, was these kinds of things that you could do were not incredibly hard. You didn't have to get, amazingly expensive gym subscriptions and great new Lycra clothing and do huge amounts of exercise. Actually, just small amounts of habitually changing your habits over the long term, because we've got lives in decades and decades. Those were the things that actually affected the real sorts of changes. And the beauty is they're doable. Most health advice looks very daunting and things that you don't want to do, and there's every joke in the world about, living longer and not having the enjoyment and so forth. But the kinds of things that really turn out to be very useful and measurable in better telomere maintenance in cohort studies are things that are just small but habitual changes. And so to me that was very encouraging. And again, we thought this is the sort of information that should be out there, because there's so much health information out there that when it's quantified against how well your telomeres are maintained, which then in turn translates into probabilities of not getting, if they're better maintained, not getting cardiovascular disease, Alzheimer's, really interestingly, and some cancers and diabetes. Those things are, the better your telomeres are maintained, the lower your chances are of those things. That's not the only thing going on, but it is one of the factors in human lives that does affect your probability of these. And so knowing that is very empowering, and it's measurable in cohort studies. And so you get good guidelines about what kinds of interventions or changes in habits work. And so that was what was so interesting, that they were not extreme ones. They can just be things that cumulatively add up. So we talked about different areas of things that you could look at in your life, So it's everything, basically, there's nothing new here. It's basically everything your mother told you. Right? So sleep well, have a good attitude, get some exercise, eat decently, have interact socially well with people, all of those things that we all know, but it gives some quantifiable guidelines as to amounts and so forth. So you can look at all of these and know that, making a few changes in any of them are going to be helpful. You don't have to change everything at once. So this is what my colleague Alyssa Eppel, who wrote the parts of the book that of course talk about this, draws from behavioral science, understanding, what things are actually useful for making things change. Because you as a physician, I'm sure, told your patients you have to do such and such, or a terrible thing will happen to them, and they take no notice, right? So, right. So there's been a lot learned about what makes people actually want to make changes and have changes that stick, because that's the idea. So I've learned a lot.
Can we go deeper in there to play on Steve Jobs' quote we saw up there, that
yes, that was wonderful.
That DNA alone isn't going to, technology alone isn't going to solve everything. So in our body's case, DNA alone doesn't define who we are. There's lots of things we can do to our DNA.
Yes.
So can you give us more specifics, like how much exercise is the right amount? You have a chapter in there talking about that.
Well, yes, because it was such an interesting question. So I'm going to put it in so nothing works by itself. We are the interaction of these things. But my favorite one is that in people who are under chronic stress, and there are situations in life like long-term family member caregiving, for somebody with Alzheimer's, or a child who's got a chronic condition and the mom is the one with primary responsibility, not much help, things like that. So when these situations were studied, it was found that even as little as 15 minutes of just quite brisk, but work up a sweat a bit, exercise daily, was enough to buffer the stress's effects on the telomeres compared with those who didn't have such exercise. So that's not an crazy amount. at all. And I always like to say, if your lunchtime's short and you feel I have no time for exercise, you actually do have a bit of time to, run up and down the stairs. So surprisingly small but consistent amounts in a sort of sensitized setting of somebody under chronic stress really could help. And in fact, another way we could look at it is to say that the benefit of exercise was about twice as much if you were, for your telomere maintenance, if you're chronically stressed than it is if you're not stressed. So it's context dependent. Another very good intervention study done in Germany, where they actually did an intervention, looked after 6 months and asked about different forms of exercise, was that it turned out interval training had more effect on telomere maintenance capacity than did just weight and resistance. But another big study with many thousands of people where we did the telomere measures was just the number of categories of exercise you did. Just more and more, moderate exercise, vigorous exercise, walking, cycling to work, weight bearing. If you just added categories, the telomere maintenance just went up and up. So I think variety, and it wasn't especially dose dependent. I'm sure there's a threshold, but it doesn't seem very high before you start to see the benefits of the exercise on what otherwise would have been stress-related telomere shortening. So that's one kind of very practical example.
Mm-hmm.
The intervention for interval training, it was only about 3 times a week, I think, for 45 minutes. So again, not crazy amounts. Now, one does find that marathon runners do have very good telomere maintenance by and large. Mm-hmm. We all know that there's overtraining, and that's not from telomere research, that's from a lot of other work. But one can use it as a good kind of reliable, meaningful readout for what a dose of exercise or food habits and so forth are beneficial. Sleep, 7 hours at least, was clearly differentiated from 5 hours or less. So those are sort of 2 useful guideposts. It didn't say you had to have 8.5. And that mattered more, again, depending on how old the person was. So the older you were that became a bigger effect. So again, it's very context dependent.
You're making this sound all very doable for the rest of us.
The point was that actually this was science. I mean, this is measured things. It was not an opinion. That's what I love about it. I never thought we'd see anything, and so the data just came at us and came at us and came at us. And it's always best when that happens. When you come as a sort of, come on, there's not going to be anything there, and then to see data just coming at you, to me, is the most satisfying, because it says you didn't kind of squeeze the result into your favorite idea. The humans actually told us what the realities are, and then human genetic studies have been very useful in reinforcing that this is causality, that this is actually a contributory factor to the disease risks, and not just a sort of marker that goes along with it but didn't really have anything to do with the process.
We just heard there's all this encouraging data. How many people here would like to learn how to measure your telomeres? Okay, what could you share with us? How do we do it?
It's not really that useful, because it's a very, when I tell you that an 80-year-old more often has telomere lengths similar to a 30-year-old than not, you'll see, and you say, what's the use of this? It's when you look at the numbers statistically in well-designed large numbers, statistically reliable, that you see that you're changing the odds of diseases. And I like to make the analogy with smoking. So we know the decision should be don't smoke or stop smoking, right? So why do we know that? Because of a lot of studies in people. Do you need to take your own lung biopsy to convince yourself not to smoke? You don't. You wouldn't get any useful information. You would still know that the body of evidence was smoking will up your chances of many cancers. It won't guarantee you lung cancer. Not smoking won't guarantee you freedom from cancer, but boy, it'll change the probabilities. So my feeling is there's no harm in measuring your telomeres, but there's a lot of, we've studied this a lot in our research studies. It sort of fluctuates up and down. There's a drift downwards, but you don't get a whole lot of individual information. But there's no harm. I mean, you know, won't hurt, but it won't tell you a whole lot. Where I think it's going to tell a lot, which hasn't happened yet, is when that measure starts getting combined with other measures. And there's some studies that have started coming out in, sadly, cancer patients who already have a diagnosis of cancer. And when telomere length, just in the white blood cells, shortness, you know, the degree of shortness was combined with just, you know, one or two other measures, it became a much stronger predictor of prognosis after you corrected for all the other factors. So when we think, you know, our long life and our longevity is now, these days, very dependent on how much we are able to not get or survive, you know, cardiovascular cancers, diabetes, you know, the biggies, right? Lung conditions. Anything that is upping our odds of not getting those is going to make us more likely to be in a longer health span. You know, we call it health span. And the interest in longevity, you know, how long can we live, you know, lives where we live our potential at its best is to do with our health spans. And so this is really what this science was all about. Not, you know, can we live forever? That's for another day, but you need to at least get through, you know, a good health span before we can even get to that part of things. So I'm all for, you know, making sure we have the highest quality of health, and this is one part of it, but you know, I know there'll be more going on. It's just the one part that we actually do have a real good handle on now for those long decades of human life. We understand that that's, you know, something that's really playing a quantitative role.
What do you think is leading to this surge of interest in the field of healthy longevity?
Yeah, well, I think it's the success of medicine, right? The success of medicine was to and you know, public policies that led us to have, you know, safer water and things. So now we're not so worried about, you know, losing. I mean, we are in some parts of the world, believe me, I don't minimize the seriousness, but the fact that we have sort of almost the luxury of this is because medicine and scientific advances in, you know, taking care of a lot of the infectious diseases. You know, we're really good at broken legs, and you know, we're good at a lot of awful things that might have killed people. And so now we're in this stage where we have the luxury of looking and saying, well, you know, we now can start looking at the next things that are threatening our health span and therefore our quality of life, and of course indirectly our longevity. And so it's just where we are in terms of the way things have advanced. So it's a you know, it's a triumph of medicine that we have now got this ability to think about these things, and a triumph of research in so many areas that there's so many ways that we can start understanding what's going on. So you know, we dread what's going on in terms of, you know, the dread of Alzheimer's and the dread of cancer and so forth. But I really think that there's, you know, inroads that, you know, as you go into the fundamental science of how the brain works, how cancer's worked, you know, we're getting there. And so I think this is, maybe people have just started realizing that, you know, we can look beyond just, you know, surviving childhood and typhoid and smallpox and polio, you know, things that were the big dread things in the 50s. Polio was a terribly frightening disease for families in the 50s, and now most young people, you know, barely have heard about it. So that's success that comes out of doing research and understanding how, you know, how disease etiology is. This is now an understanding of a different kind of disease etiology. Only one kind of understanding. There's more to it than this, but it's one part.
That was Jonas Salk's work with the polio vaccine. Within the aging field now, what are some of the things going on in terms of research that's exciting you, that's very intriguing?
Yes, well, the telomere part, I love it. I think we've got our heads around some of it, but the big thing will be, how do you start combining that with, as I said, we're one integrated person, right? How do we start combining that with other things that really will make very big sort of individual predictions much more strong? But the other, and they may be genomic, they may be epigenomic. The epigenome is all of the chemical marks on your DNA that makes genes get expressed or not. And they get changed by life circumstances, as do telomeres. And then some of the very exciting basic findings in research that I'm excited about is how, there are proteins. Proteins are, the molecules that make up our cells and do all the things that enzymes and so forth. Basically life depends on proteins. We're bags of very intricate proteins. And some proteins get constantly renewed, because they get sort of old and sort of shabby chemically, and so the cells renew them. But some don't get renewed. Some in our brains will sit around for decades, we believe. And they get a little kind of fuzzy, they're not great. And so that contribution to aging, and it maybe some of those lead to some of the, the brain disorders where you have proteins that have become, tangles and plaques and, junk protein. But this understanding of the way cells can replenish those proteins. It's just that our brains are kind of a little too lazy to do it. We live all these long years. We weren't evolved to clean them up. But cells have the capacity to do it. And if you could wake that capacity up, there's somebody at the Salk Institute, Martin Hetzer, who looks at this, and he knows that in your brain cells, they don't have the capacity to clean out these really ancient proteins. I call them the undead. They're the zombie proteins. You wish they weren't around, but they are. But the cells that gave rise to your mature neurons, they've got that capacity to renew them. So if you can just wake it up in the neurons, and so people understand a lot about how these pathways can get turned on and off. So I could see that we could maybe in the future just wake up those, clean out the garbage a bit, clean house a little, get something nice and spiffy and new for proteins. So I'm just thinking of one of the lines of research that is interesting. When telomeres get too short, they make our energy powerhouses, the mitochondria in our cells that deal with all our molecules that give us energy and that we metabolize well or not so well, not so well giving rise to metabolic syndrome, diabetes. That telomeres play into that. Love to know what else plays into that. And so again, working on metabolism and our energy powerhouses in the cells, I think those are going to be exciting. I could go on, but I'm just giving you a couple of examples.
Well, we can close on maybe on one note in the remaining time. It's a connection to, and we just heard earlier from Angela and Lucy, the human connection part, which was a really great section in your book. Can you describe the effect of human connection on health?
Yes, well, we know all these health behaviors, affecting our telomeres. So what about, do you affect other people's telomeres? We know how intensely social humans are, as we heard Angela talking about. And so we wondered, what would you do to somebody else's telomeres? And so on the really depressing end, children exposed to violence, bullying, racism, those were impacts that were measurable on telomeres dependent on the number of years of these. And then in adults too, similarly, people exposed to violence. The good news was people in very positive sort of long-term relationships, be they friendships, be they marriages, you could see these positive measurable effects on telomeres. And something so ephemeral and hard to grasp, yet you could see effects on telomere maintenance. And one of my favorite studies was a study which was a very intense meditation retreat for 3 months. And what was assessed, self-report, was purpose in life and change in purpose of life. Something very hard to put your hands on. And that quantifiably, how much more people, increased their purpose in life as they perceived it, quantifiably related to their telomere maintenance capacity change. We were just really impressed by that kind of thing, because purpose in life, as we heard, is very often associated with how you interact with the world, what you give to the world, your relationship to the world. It's partly related to you and what you do, but a lot of it is what you are doing in relation to your family, your society, your community. So I find it fascinating that these things can be not reduced to, but sort of shown to have this quantitative relationship, because it gives it a bit more, solidity in some people's mind. It doesn't sound quite so woo-woo, to some people say, well, these things do actually quantifiably relate. Our brain does affect our physiology, and this is one kind of measure.
Well, it looks like we are out of time. Maybe eventually we're going to all run out of time, but we learned today about how to make better use of that time.
Good pun.
Really exciting to hear about all the work that's going on. And thank you for spending time today. It's been very inspirational.